Everyone, I'm Mrs. Hema Sagar Kumbhar, working as Assistant Professor in Department of Computer Engineering, PICT Pune. In this video, we are going to discuss about the third normal form. Third normal form, it is basically called as a 3NF. A database is said to be in the third normal form if it satisfies the following conditions. Initially, it has to be first follow the second normal form criteria, and the second one, there should not be any transitive functional dependency. So we'll discuss what is about the transitive dependency. So it means if A follows B and B follows C, then we can easily say that A follows C. So this is basically a transitive dependency. So to be in a third 3NF, a database or relation should not have the transitive functional dependency. So transitive dependency cause update anomalies. Hence, to achieve the 3NF, we have to eliminate the transitive dependency. The transitive dependency occurs when a non-prime attribute is functionally dependent on another non-prime attribute. So we'll take an example. Suppose there is a relation R which has three attributes. So there is a relation R which has three attributes, and these are the functional dependencies which are present in this. Now we'll first identify what is the candidate key. So the candidate keys are the set of those attributes which determines all the attributes of that particular relation. So here we can easily observe that P is a candidate key for this relation because P determines all the attributes. How? We'll see. So P determines Q. This is the P which identifies itself, as well as because of this functional dependency, it identifies Q. And because of this functional dependency, it identifies R. So in turns, P identifies all other attributes of the relation, that is P, Q, R. Hence, I can say that P is a candidate key of this relation R. If you see for the other two attributes, that is Q and R, it does not determines all the attributes of the relation. Hence, we cannot say that P, Q and R are the candidate keys for this relation. So, prime attributes becomes my P and non-prime becomes my Q and R. So according to the 3NF, it has to be first in 2NF. So yes, so this relation is in 2NF because there is no any partial dependency. But there is a presence of a transitive dependency. How? Because P arrow R. P functionally determines R. Because we have this relation P arrow Q and Q arrow R, P is transitively dependent on R. So because of this functional dependency Q arrow R, this transitive dependency is there in this relation. So we have to eliminate this Q arrow R to be in the 3NF. So how to resolve this? We have to decompose our relation. So we have seen already the thumb rule for the decomposition. We have already seen in the previous two videos when we are discussing about the 1NF and the 2NF, how to decompose. So the same rule is to be followed for this. Suppose we have a relation R and there is a functional dependency X arrow Y, like X determines Y, and this is a functional dependency which causes the violation rules. Hence, we have to calculate X closure and Y closure. So X closure, it means the attributes which are determined by the X, and Y closure is the attributes which are determined by the Y. So first decomposition R1 is nothing but your X closure, and second decomposition R2 is nothing but your relation minus Y closure. So according to this, first we have to identify the functional dependency which violates the rule. So this functional dependency which violates the rule, that is Q arrow R. Hence, we have to calculate Q plus and R plus. So Q plus is the attributes which are determined by the Q. So Q determines Q itself, and because of this functional dependency, it determines R. And what is R plus now? R plus is R only because there is no any functional dependency which is determined by the R. So here first decomposition is my Q plus, which is nothing but Q and R. And second decomposition is R minus R plus, that is PQR whole relation minus R closure, that is equal to P and Q. Now let's look at the second example of this. Suppose I do have a relation, student relation, which has one roll number, name, department name, and department location. So these are some attributes. These are some values present for this table, like roll number, name, and department location. These are the values present. So first we have to identify what are the functional dependencies of this relation. So if you observe this table, I can easily understand that roll number does have the unique value. So roll number is there in the candidate key. Now we'll look for this key. Roll number determines, yes, the roll number determines all the attributes of the other attributes of the relation because roll number has the unique values. So functional dependencies are present over here as roll number name, roll number department name, and roll number location. Let us look at any other relationship we do have. So if we observe over here department name and the department location, I just clear it out. Okay, if you observe this department name and the department location, so for every department name, I do have unique department location. For computer science, I do have A1. Again, for this computer science, I do have A1. For electric engineering, I do have A2. And mechanical engineering, I do have A3. So this is also a functional dependency present in this relation, which is department name determines department location. So here I can easily say that key department name identifies department location and roll number determines all the attributes. So roll number is my prime attributes and name, department name and department location becomes my non-prime attribute. But because of this functional dependency, because of this department name and department location, it does not follow the 3NF criteria because non-prime attribute determines the non-prime attribute. So yes, and is it in 2NF? Yes. There is no any partial dependency present because prime attributes only one. There are no any sub attributes of this which is determined other attributes of this relation. So yes, this follows the 2NF but not the 3NF because of this transitive dependency. So what we have to do? We have to do the decomposition. So while doing the decomposition, we have to first identify the functional dependency which violates the rule. So clearly we have seen key department name and department location violates my rule. So I have to identify the closure of those two attributes like department name closure and department location closure. So department name closure is this department name and department location, and department location closure is department location only. So yes, R1 becomes my department name plus. So this is my first decomposition and R2 is my second decomposition, which is nothing but this one. Now if you see this decomposition, this is a lossless decomposition because of this decomposition I am not in a state to lose any kind of information of this previous original relation. So this is now in this case this follows a 3NF. And thank you. See you in the next video.